Hi, this is Simon Obstell, and welcome to another tutorial for Blackmagic Fusion. And today we're going to be taking a look at this project in which glowing spheres collide with the inside of a Perspex box. So that looks like this. Now, there are a few interesting techniques going on in this, and the main one I want to highlight is that we're going to be using expression to create those spheres and their bouncing movement. So that's going to be quite interesting. But there's plenty more as well besides that. So let's get started. So let's start out by creating a 3D shape. Let's make this one a sphere, and I'm going to go for a radius of 0.1. So let's have a look at that. So let's call this sphere, and let's make another 3D shape. This one we're going to call box. So let's look at the two of them together. So the box, let's select a cube for that, and let's come over and make it sort of semi-opaque like that so we can see what's going on inside it. So let's come back to the sphere and discuss how we're going to do this bouncing action. So I'm going to come over here to this X translation, and I'm going to add an expression. So I'm going to do this in stages so that we understand what I'm doing. First of all, let's apply time to this, and I'm going to divide it by 54 because I don't want to be traveling too fast. So time divided by 54. So as you can imagine, that's going to send our sphere off to the right-hand side. So how are we going to get it to come back? Well, what we can do is we can use the modulo expression, and now that's the percentage sign like that. So if I do modulo 2 and we watch what happens, you'll see that the sphere gets to the end of that and then bounces back to the beginning. And obviously what modulo does is it takes the input value, and as soon as it's reached 2, it resets it to 0, and we start all over again. And so now we can use this in an interesting way to get it to bounce backwards and forwards. So what I'm going to do is I'm going to put brackets around this, and then I'm going to type abs in front of it, and then after the modulo 2, I'm going to type -1. And now I want you to see what happens to our sphere. There we go, it's bouncing backwards and forwards. So as it hits a value of 1, it comes back the other way. So the only problem is that it's not centered up on our box, as you can see. So it's very easy to fix that. All we have to do is at the end of everything, we type -0.5. And that'll just reset that to be in the center of our box. Because obviously our box is 1 unit wide. I just need to extend our timeline to 1,000 pixels long so we can see this properly, because we were seeing an odd sort of bounce there because it was too short. Hopefully now you can see it's nice and smooth at both ends. And we can vary the pace using that multiplier or that divisor on the time there. So we can make it much faster by going for, say, 24. And there you go, it's bouncing around pretty fast. So what we can now do is we can add a new expression to y and paste it in. And let's just vary that time factor. Let's go for 36 for y. And then we'll need to have a look at the front view like this. You'll see that we've got the sphere bouncing around inside our cube. And obviously we can do the same thing again for z. So add an expression to z and paste in that expression. Let's switch up the time multiplier again. Let's go for 48 there. And you can see this path that it's taking. It's now bouncing around on Z as well as the other two axes. So a very, very simple little expression that's been extremely useful here. Now I want my box to be double the dimension on Z. So let's just do that. And let's unlock the scale and let's set the Z scale to 2. And now if we look, our box is double the length, but we need to now fix our Z animation. So let's come back to the sphere here and this expression on Z. So what we're going to do is just simply going to multiply those numbers by 2. So modulo 4 -2, and then -1. And now that's bouncing down the length of the box like so. Now, if I make the box fully opaque, you'll notice something that you've probably already noticed before. Let's make it dark enough we can see this. Make this almost completely opaque. So what I want to show you is that the ball is actually, as it hits, as it were, it hits the side. It's not bouncing off the inside edge, and that's because the ball itself has a dimension that we need to take care of. So let's just remind ourselves of the dimension of that ball. We chose, over here, we chose a radius of 0.1. So what we're going to do is we're going to come to this expression, and instead of modulo 2, we're going to go for 2 minus 4 times 0.1. So 4 times 0.1 is obviously 0.4, so we need to subtract 0.4 from 2, and that gives us 1.6. And we need to do that for all three. Then we also need to adjust these other two values as well. So from this, we only need to subtract it twice. So instead of -1, it's going to be -0.8. Let's do that for each one. And we also need to affect this last value. And this time we only need to subtract 0.1 once. So that 0.5 will become 0.4. Same here. That 1 will become 0.9. And now, if we look, I think you can see that we're safe. The ball actually doesn't come outside the box. Now, you'll probably notice that our box is actually not sitting on the floor, which is making it look a little bit odd. But I can actually just quite easily fix that by coming to the merge, and we can enter a value of 0.5 for y. And then you'll see that our box is indeed sitting on the floor, and everything is going to look correct. And the ball is not going to come outside at any point, but it's going to hit each of the surfaces perfectly accurately. Now, I find the sphere just a little bit too large for this box, but I wanted to show you a simple calculation. What I'm actually going to do is I'm going to reduce the size of that sphere down to 0.075, and then we need to change up these numbers. I'm just going to paste these in. So what we've done exactly the same thing, but just with a different value for the ball. So we've got different numbers accordingly. We've subtracted 4 times the radius of the ball here, 2 times the radius of the ball there, and 1 times the radius of the ball on that last number. So that's how we arrived at those figures. So currently we've just got the one sphere, but we can very easily turn that into more spheres if we want by just using the Duplicate 3D tool. So let's make 3 spheres, and all we need to do is change the time offset. So I'm going to go for something like 27. And now if we play, you'll see we've got these 3 different balls chasing each other around, and that's going to be pretty good, I think. Now, obviously, we can't do anything about the fact that balls are intersected, but I don't think we're actually going to see that once they are glowing spheres. We can't even see it now, actually, because they have got no textural lighting. So let's now look at adding a floor. So I'm going to add another 3D shape, and we can add it temporarily to this merge here. I'm going to rotate it through 90 degrees on X. I'm going to set its scale to 40. And then we need to bring it down on Y because of what we've done to that overall merge. So let's bring it down there. And now everything is sitting on that floor. And let's just rename that as floor. So this is all looking a bit horrible. So I've brought in a texture, and I'm going to use that on my floor. So I'm going to add a blend to this texture, and then I'm going to add that to the floor. I've also brought in this dirty glass texture, and again I'm going to add a blend. We need to remember here that we need to adjust its opacity. Let's go down to 0.4. So we're going to use this for the box. So let's have a look at where we are at with that. So a lot of work still needs to be done. The first thing I want to do is I want to add a scene light. So I'm going to add a 3-point light. I'm going to add it to that merge there. We'll probably need to turn on 3D options lighting to get a feel for it. So let's just adjust its position. We're going to have 1 on X, 1.5 on Y, and 1.5 on Z. This is going to provide a sort of a gentle illumination to our scene over here on the right. But a more important illumination source is going to be the 3 spheres themselves. So to do that, let's add another 3-point light. And what I'm going to do is I'm going to grab that 3D, duplicate 3D, copy and paste, and then add that point light to that. So we'll now have 3 copies of that. Pop it into our merge. So what we'll need to do is to get this light to follow the sphere. So we can do that by applying an expression to its translation. So I'm going to type sphere and then transform 3D op. Let's see that. Transform 3D op dot translate dot x. So make sure you type that right, or if you're lazy, you can use Pickwhip instead. I'm going to make an expression for y and paste that, copy and paste that into there, change that to y. Same with the z, add an expression, paste that in there, change that to z. And now those lights are following the spheres. What we'll do next is to add a 3D render node, but we'll first of all have to add a camera. So let's add a 3D camera and let's pop it into our merge. Let's just choose from the camera menu here in the viewer, copy POV to camera, and then our camera's now got that viewport view, and we can add a 3D renderer to our merge, pipe the output of the merge into it, and then look at the result. And so we're now looking at the scene through the camera, and then we can turn on the lighting for the renderer. Now, some obvious problems here. I'm just going to move the camera down a little bit on Y so we can see. I'm sure you can see that we've got a problem here with the floor, and it's intersecting the box. And we need to make a very small adjustment to the position of the floor to remove that. On that Y value, instead of -0.5, I'm going to go for -0.501. And that just moves it down by a fraction, and it solves that problem of those intersecting polygons. Another small thing I want to do at this point is to add a background, and then I want to composite the renderer output over the top of that background, so we can just disregard that area at the back where the floor falls off into the darkness. Now, another issue we have is that our spheres are of sort of black and being sort of partially illuminated by their own lights, but they're not the kind of thing we're looking for at all, because we want them to be glowing in their own right, self-illuminated. So what we're actually going to do is we're going to take this sphere and its duplicate 3D, and we're going to disconnect it from that merge. And then we're going to copy that merge, paste it, add that to the new merge, and also add the camera to that new merge. And then we're going to add a second 3D renderer. So look at that. You'll see our spheres are white, and that's going to allow us to create our self-illuminated elements. So I'm going to merge that over the top of my final merge like that. And once we've added some glow to those are going to look really nice. Now, there's another crucial thing we need to do, and that is to find a way of getting the spheres, or the sphere's lighting, to illuminate the inside of the box. At the moment, they're literally just lighting up the floor, but because they're inside the box, they're not illuminating the inside faces. And to fix that, we're going to come to the blin for the box. And here, we're going to turn on two-sided lighting. And immediately you can see the difference that makes. We're now getting that illumination on the inside of the box, not just on the floor. Now, there's another thing we need to do with our box, and that is to add a specular map to the blin. So I'm going to add a luma keyer, and then I'm going to pipe the dirty glass into that, and then I'm going to pipe the output of the luma keyer into the specular intensity of the blin. And then let's just adjust the luma keyer, bring in these values, something like that. So we're really tightening up that specularity. And then we can come to the blin itself and its specular, and let's just increase that specular intensity to 3 because I really want those highlights to kick a lot. So I want to turn my attention to the floor next, but I just want to adjust my camera and I just want to rotate it around. So I'm going to use a trick that I usually use, which is to add an expression to the Z pivot and then to pick whip the Z translation and then add a negative sign to the front of that expression. Once I've reset everything, we're now in a position to adjust the Y rotation so we can look at the box from the side like so. So I find that quite a handy trick. There's probably a better way of doing it, but attaching the pivot to the Z pivot to the Z translation does give you that nice ability to just rotate, just to orbit around using the Y rotation control. Now our floor is really not looking good at all, so let's do some work on that. And just as with the blin for the box itself, I'm going to add a luma keyer. Add a luma keyer, take the output of the floor map, and then pipe the output of the luma keyer into the specular intensity of the blin. And again, let's adjust it something like this. And then what I'm also going to do is I'm going to take that and use it for the specular exponent. Now the floor is being mapped onto the entirety of the area and we don't really have nearly enough resolution for it. So we're going to fix that by adding, after the floor itself, a UV map tool. So planar is fine for the map mode because we're just mapping a plane. So let's have an X value of 8 and the same on Z. And then let's just move it back, I think, around -2 on Z. The rest, I think, is going to disappear off into the darkness once we've got our lighting sorted out. And then what I'm going to do is I also apply a brightness contrast to this floor texture. And let's just increase the brightness and contrast like that. So then I'm going to come back to my lighting, my scene lighting, and make some adjustments. So this main point light here that's providing the overall scene illumination, let's adjust that. I want to go for a linear decay and reduce the intensity down to 0.7 and the decay rate to around 0.75. And that's just got things under control a bit more. And you can see how that specular map is rather nicely giving us some bright areas and then some areas that are not being illuminated. And when everything is on the move, that's going to look really good. And I also want to adjust the point light that is being duplicated for the spheres themselves. So let's come over here. Let's select quadratic for the decay type this time. And we can reduce our intensity down to maybe about 0.2 and just adjust that decay rate again down to about 0.75. And you can see how dramatic that's starting to look. So there's a couple of extra things I want to do to the box. And one of them is to create an extra layer. And to do that, I'm just going to copy that box, paste it, and add it to the merge. And then let's come over and adjust it. What I'm going to do is set a scale of 1.04, so it's slightly larger. Let's come over to its material properties. I'm going to just increase that grey value a little bit. Then I'm going to come down here and turn on two-sided, which obviously we need. And I'm just going to reduce that exponent value way down to around 4.5. And this kind of created this kind of perspex look, which I think is going to work better. So if I disable that box, you can see it's got this interesting kind of diffusion effect. I think that's going to work nicely. And another thing I did, and I'm not going to waste your time in this tutorial, is I built a frame for it. So I'm just going to add that to the merge. Just gives it a little bit more visual interest. And I built that just using basic cubes and duplicating them and then adding an aluminium texture. But that's all really basic stuff that you don't need to watch me doing. So now we come on to the final interesting part, which is how to make the spheres look like they're glowing. So if you remember, we created this renderer which isolated them, and then we're merging that back over the top of everything. With that renderer selected, I'm going to add a blur. And what we're going to do here is going to set this blur size to 16 and the blend value to 0.8. And then we're going to copy and paste This new version, we're going to set the blur size to 32 and the blend to 0.6. Let's do it one more time. Copy and paste. This final one, set that blur size to 64 and the blend to 0.4. And then I'm going to add, after that, a color corrector. So the color corrector, I'm just going to add a little bit of a blue cast to it. And then the important part is to increase the gain. So let's go up to 4 with the gain. And I might also just slightly reduce the gamma. Let me go for something like 0.85. Just tidies up those edges a little bit. And now you can see we've got that effect that we're looking for. Those spheres are actually looking very much like they're inside the box. So we're getting this nice sort of refraction here, and yet they're actually outside it. And what we could do is we could get very sort of picky and reinstate the box very faintly over the top, just in order to get a sense of this. But I don't think that's necessary. It's really up to you. You can go that extra mile if you feel that's something that worries you. But for my money, I think that's looking okay as it is. So, I hope that was interesting. Thanks very much for watching.